So the next and final property of logarithms that we're going to look at is talking about some log to a power of a power, right? And so we know from the beginning or yesterday's video or earlier video that log base like 4 of 4/3 is really just equal to 3, right? But why is that? Well, it's because of this property right here. It says that log base x of a to the b, we basically can drop that b down and it becomes b times log x of a. Okay, so we can use that information to actually help us figure things out. Now, let's look at this one right here. It says log base 2 of 5 is approximately 2.3219, and we can figure out log base 2 of 25. Now, how do we do that? Well, we know that 25 is actually written as log base 2 of 5 to the second power, right? Because 5 times 5 is 25. So according to this new product rule, I can actually bring the 2 down and rewrite it as 2 log 2 of 5. And so since we know that log base 2 of 5 is that decimal, we can just substitute it in, actually. And we'd say 2 log, actually, we don't even have to write log anymore because we know it's a decimal. So it's really 2 times 2.3219. And so that is equal to, and I go on my calculator, 2 times 2.3219, and we find it to be 4.6438. And again, if you wanted to check your answer, it's really saying, okay, so 2, so if we think about this, 2 log base 2 of 25 is equal to 4.6438. And so I could just do the loop rule and check to make sure it's true. So 2 to the power of 4.6438 is equal to 24.9999. So that's pretty close to 25, right? So we know that we are correct when we say 4.6438. And we use our approximation of our log base 2 of 5. Okay, so let's put all of this together in one problem. Okay, example 4. It says we are asked to solve for x now when we have log base 6 of x plus log base 6 of x minus 9 equals 2. So I see an addition problem and I see 2 log base 6's, right? Log base 6, log base 6. So that actually means that I can rewrite it and plug it in together, right? So I'm going to write it as log base 6 of x times x minus 9, because we said when there was addition, it's really multiplication, is equal to 2. So using the loop rule, okay, that we talked about in the first one, 6 to the 2 power should equal that whole multiplication problem. So we're going to say that. We're going to say 36, because 6 to the second power is 36, is equal to x times x minus 9. Okay? Now we distribute, and we say 36 is equal to x squared minus 9x, right? And so if we wanted to solve this, right, we would subtract 36 from both sides, and we would say that x squared minus 9x minus 36 equals 0. Now, how do we solve a problem like that? Well, if we're interested in solving a problem like that, there's lots of different ways to solve quadratics. The easiest of which, Desmos. We graph it, right? So we're going to do that. We're going to say x squared minus 9x minus 36. And I get 2 solutions. I get, it says 39. We want 36. Okay, I get 2 solutions. I get -3 or I get 12. So I go back here and I say, well, x equals -3 or x equals 12. Now, I'm going to let you in on a little hint. One of these is not right. But which one? Think back to section 3.2 when we talked about logarithms, right? For the first time, we said that you cannot have a logarithm of a negative number because something to a power is never equal to a negative. So automatically, I can cancel out and say that that is not an answer. And the only value of x that works is 12. Okay? So we know for a fact that 12 is going to work. So if we were to put that into our equation, right, log base 6 of 12 plus log base 6 of 12 minus 9, which would be 3, log base 6 of 12 plus log base 6 of 3, that would equal 2. And there's lots of different ways to prove that that's worked, but we're not going to do that at this point, okay? All right, very good.